No, nothing. Change the slide. Can you change the slide, please? No, here.
So I will move it from there.
No, it has to change from here now.
There, the system is there.
Right now, my question is, you can repeat the question. There are 12 POs and there are 40 courses. We design these courses with the POs. Some may have courses, some may have 8 courses. So we don't have any come backwards from POs to design the
Sometimes you have to do a little creatively at the time of curriculum. We'll talk about that tomorrow. Still. Okay, I'll come. Let me write this. Okay, if you are able to hear from me, then I should not come forward. Okay. You can graphically accept this as the mechanism. This is valid for the okay. You have vision of the institute, vision of the institute. Okay. That is always there, NAC or NBA. You have to give that. And then you have vision of the department and mission of the department, which is in alignment with the vision and mission of the institute. And then here what happens, you have a department advisory board or board of studies or whatever other name that you give. Some board will identify through certain process, well-defined process, the program educational objectives. And then they also identify specific program outcomes, program specific outcomes. And NBA gives you the identifies the program outcomes. And actually, your curriculum should be designed top down. That is, you don't. Right now, we have already list of courses. Somebody has finalized that, and then you work backwards to write the statement. But ideally, if you are redesigning your curriculum, you have to start from the top.
You may just
Okay. And together, these program outcomes and program specific outcomes together should lead to the curriculum. Curriculum consists of what we call curricular components, which are also defined by AICT, which include humanities and social sciences, basic sciences, engineering sciences, professional course, professional electives, open electives, and project. And majority of them, other than the project, they all have several courses. And course is described in terms of course. Graphically, that is the relationship between all the elements as per the NBA and AIC. Okay. And now this is where we were trying to pause. Maybe I will still pause here and ask you if you have any questions. Are there any questions about You have any relationship between POs, PSOs, and COs, curriculum design, if you have any issue.
So how to map lifelong learning, so P12, PO12?
Okay, we'll talk about that when we come to that PO12. That's what we are going to look at each PO. First of all, PO is not a box to be ticked. Ticked or not ticked. If we have to elevate ourselves a little above the ticking the box. Because when you look at it, for example, PO2, and for that matter, any PO which we think it's taken for granted, we are not doing anything of that kind. We will see presently. Yeah, we will come to that PO. Any other issue at this stage? Okay, we will proceed. So we will spend some time on program outcomes. This is something that you have to internalize and develop a respect for it. Here, POs are what graduates of any engineering program should demonstrate at the time of graduation. They are not program specific. And they are similar and in alignment with what you call graduate attributes of Washington Accord. They use a different word. They call them as graduate attributes. We went through some dynamics logic at the time of 2015 and settled down on the word program outcomes, POs. And whereas, for example, EBIT itself, which talks about, which is the leader in this, they were talking about A1 to AK, they were talking about just merely named it like that. Under criterion 3, I think of theirs, A1 to AK, they've reduced from 12 to 11 in EBIT. Now, even NBA is proposing to reduce the number by 1 and it will become 11 in future. It is not formally announced. Because there are two outcomes which are very similar. So they said, why have two and kind of reducing it? We'll come to that. And only 5 of the 12 are dominantly disciplinary outcomes. When you look at the statement, you can look at it, it is all related, you can readily relate to your discipline. But the other 7 are professional outcomes, are also known as generic or transferable skills or transferable outcomes, which I have explained what they are. And 3 POs mention what we call complex engineering problems. And they are 2 POs mention complex engineering activities. And 2 POs mention what is called contextual knowledge. Contextual knowledge is something very different from absolute knowledge that you talk about. Okay. Now,
Sir, you say disciplinary. In the good old days, there used to be a civil and mechanical,
yeah.
and maybe electronics or electrical. Now, if I compare CSE, computer science, with the information science, they're not very different. So will the POs be very different between CSE and ISE?
Yeah, they can be simple. PSOs can be very
The
almost.
first 5, which are saying is disciplinary, I can say civil is very different from mechanical.
Yeah.
But CSE, computer science, is not very different from information science.
It doesn't have to be that you made it different.
Not
Whatever it is.
No, when we're defining, sir, we have
But for different reasons, sir. Why were so many CSA programs were created?
No, that's my problem, sir. I'm the one who's trying to finalize the curriculum. We have 5 streams in computer science related disciplines. So when we are defining this for the next stage, how do we make them different?
Don't make them different. They are not different.
They can be same.
Almost. You can change one word in one sentence. You can because each program is being seen independently, right, of the other. So to that extent, even if you exactly use the same words, it doesn't matter. Okay, uh, because those programs were created for a different reason that we all know. So, uh, whereas private universities don't suffer from that, but they're also coming into the same kind of thing. Private universities are saying that they are different, they're giving different degrees because they are in line with what is the current fashionable fields. Anyway, the complex engineering problems are not the problems that we are solving in the classroom, right? When do you call something as a complex problem? Pardon?
I need this kind of output, outcome.
No, on what basis do you call something complex?
Takes a lot of time to solve.
Okay, that is one part. If I am bad at it, then I'll take a lot of time and not solve it also. No.
Variable relationships are not clear.
Okay.
Can you solve the solution for the unknown problems?
When you,
Can you try to solve the solutions for the unknown problems?
okay, unknown or ill-defined problems. Ill definition or unknowability are they only criteria for a complex problem?
Design based.
Or the design is complex. When the design is complex,
Designing it complex means what?
Giving
Might
multiple
be said out.
solutions. Giving multiple solutions, different ways.
Giving multiple solutions is not.
Conflicting each other.
Okay, you are somewhere there, but it has to be a little more evolved. So once again, all of you should clearly understand what a complex engineering problem is before you tick the box. Uh, First of all, it has problem itself has a wide-ranging and conflicting technical, engineering, and other issues. Just during lunchtime, somebody was asking me, how do you improve the quality of learning of your students? Is it a complex problem?
Yes.
Okay. Why is it a complex? Why do you consider it a complex?
because we try to attempt multiple times.
But now he gets all different perspective,
Yes, because someone said it.
different perspective. Cognitive,
Multiple perspectives.
Multiple
perspective.
perspectives. Okay. So what happens is the moment you come to education already, which is supposed to be right in your control, you acknowledge that you have multiple perspectives of the issue, and that is one aspect of complexity. That means there is a human dimension to that. While I can give so-called technically justifiable solution, but it's not acceptable.
So the problem which is difficult to solve,
Difficulty is another.
not easy to solve.
Yeah, but difficulty is related to maybe I do not understand some mathematical relationship between the input and output. Okay, or that mathematical relationship is complicated, very complex equations that are coming. But complex engineering problem is characterized by you have first of all conflicting technical, engineering, and other issues. Take any political issue that right now all the time we are looking at. A solution that you produced in some northern state will not be applicable in another place, right? Will not be acceptable at all in some other state. So there are so many dimensions to that about which one doesn't have clarity. Let's say you take a problem like how do you solve a problem related to traffic in Bangalore. There are obviously technicalities associated with that. But there are any number of human habits, the way we behave or the way relate to one another, there are endless number of issues like that. And Many of them do not have an obvious solution. Okay, there are no obvious solutions for that. And what happens is, and different stakeholders. We also have in a college like this, we have the stakeholder, parents is one stakeholder, faculty are another stakeholder. Do you think that both the stakeholders have the same goals? No. So, and what happens if you produce one solution? It will have different consequences in different contexts.
Sometimes we try to solve a problem which is not easy to understand.
Yeah, easy to understand me. Yes, you can say that that is what it is. You have conflicting, somewhat ill-defined. When you say something is ill-defined, that we do not know completely. It cannot be converted into a set of equations. We saw. I do not know. Yes, possibly it is. And then what happens is the problem has many different uh, parts and components. Unless you solve all of them in an interrelated way, you do not have a solution. If your engineering problem is having all these features, not one feature, all these features we look at it as a complex engineering problem. Do you address that during the 4 years, any complex engineering problem? Do your students or faculty address anything like that?
Yeah, we are going for rainfall predictions.
Huh?
Rainfall predictions, we are having same problem. Rainfall predictions which we use, models,
Okay.
it's a probabilistic model. That accuracy is hardly 85% only. So
Okay.
we are struggling to improve.
No, but that is your modeling exercise. Because the underlying phenomena are too many and about which we do not have all the data, precise data. So your modeling accuracy will not be more than 85%. Yes, you can consider it as a complex engineering problem, but you are not controlling the weather.
Yeah,
You are only modeling.
exactly.
Okay? So here when we say complex engineering problem, where you are trying to find a solution. Now, I will give a few examples of my choice. You are trying to plan is supplying water for irrigation and drinking to a group of villages in a arid zone. Okay? If you take that, it will have all kinds of issues. Okay? Design an instrumentation system for managing available water and its utilization in a river basin. You have every day between Karnataka and Tamil Nadu about Kaveri water, right? And you try to solve a Kaveri water issue. Yes, it's a complex problem, engineering problem. Design a system for construction of large-scale poor and middle-class housing in towns with populations less than 2 lakhs. May not be that very complex, but still a complex problem.
But why population? Why is the population part coming in there?
Why not? Because the kind of resources that you have, the kind of thing, a solution that you work it out for a place like Bangalore will not be applicable there, or even justifiable there. So, what do you mean by 2 lakh population? In India, it is too small.
Yeah.
In a town, 2 lakhs is nothing. Whereas if you go to a USA, 25,000 is it's a big town.
That's what I mean. In a smaller town,
Uh,
the planning may be easier.
Sure.
Than doing the same thing in a Mumbai or a Delhi.
Yeah, sure. But it has its own issues. You have to identify all the those issues that is decided by the 2 lakhs.
I think the question is maybe extra less than extra will maybe more than 2 lakhs.
No, more than 2 lakhs, but the comes to there you have to talk about between 2 and 10, 10 and 1 crore. You have all kinds of different problems. Now this may not become that very serious. Improve the quality of power supply to a city or a district. Okay, that has been the major issue until recently, but I understand now you no longer have what you call supply issue, not that serious compared to about a few years back. Okay, this was an interesting one, which is continuously happening. Design a system for managing elephant corridor without conflict between humans and elephants. Okay, which in Karnataka and Tamil Nadu have constant issues. Recently, finally, they have produced a solution of building a bridge for elephants to cross this highway. These are further designing resilient critical infrastructure such as power plants, water treatment facilities, communication networks, transportation systems against natural disasters, cyber attacks, and other disruptions. That will be a complex problem. Designing sustainable urban infrastructure to support growing populations in cities involves integrating transportation systems, water management, waste disposal, energy distribution, and green spaces. So one can think of these are real, truly complex problems. Okay, it will satisfy all the parameters that I have identified to call it something complex. Okay, I will not keep reading that. And now coming to very first one. This is again obsession by, first you talk about not engineering, but applying the knowledge of mathematics, science, engineering and fundamentals and an engineering specialization to the solution of complex engineering problems. Huh?
So reverse.
Yeah, it should be reversed really. That's why I just wrote the same thing. Solve complex engineering problems applying the knowledge of, yes. Okay, do you think any course that you teach meets this PIBO one fully? First of all, no course addresses a complex engineering problem, right? How can I write PIBO one actually?
No, so just like structure analysis we are having, SA1, SA2, that needs to be done with this only. And that is the second point also. Structure analysis, even structure electrical also, all they come under this category. Even food mechanics also comes in.
No, but do you have this many dimensions? Social dimension, energy issue?
Social dimension is not there, but engineering dimensions are there.
Okay, at least it's a reasonable approximation to a complex. Complexity and difficulty should not be,
No, it is not.
are not the same. Okay? So, now, first of all, how many courses do we have purely on engineering? Tell me. Our courses are basic sciences and engineering sciences. If you call something as really engineering, I do not find more than 6 or 7 in any branch. Any branch you give me, show me the curriculum, it will not be more than 5 to 7 courses. You can call officially as engineering courses. That means leave the electives. If you take 4 courses, about 30, 35, out of that, only 5 or 6 are what you may call as engineering courses. The rest of them are all engineering science or pure science or something else.
Supplementary. Yeah, attached to that thing.
Yeah. So, then, first of all, we are not solving complex engineering problems, not solving engineering problems, even to have an approximation. So, as you said, about 7 courses, yes, you can at least partially tick the box. But we readily, every course will tick PO1, right?
Yes, sir.
All get in because the problem will start with mathematics, science, and applying that. that is where that is how when you write something like this, it can lead to misunderstanding.
Correct.
So majority of the engineering courses mainly address this outcome as of today, but they tick the box. PO1, whether whether it is fully justifiable or not, at least it is partially justified. Assessment in many institutions falls far short of solving engineering problems, leave alone complex engineering problems. And end of chapter problems will at least moderately address this theme. So best that we can do is to solve end of the chapter problems in a textbook. That is the best. Even that is not done in most of the time. So the best we can do is end of the chapter problems. And basic sciences and engineering sciences do not address engineering problems directly. They do not address. So, do you think PO1 is can be readily be ticked? Okay. Again, our compromise starts right here with PO1 itself. And what are the activities that through which you can address PO1? Solve end of the chapter problems, at least that is the first level. Understand the context in which a given engineering problem is formulated. At least context if you are able to understand. And how do you do it? Do some kind of a case study.
Yes.
Case study you can describe and try to somehow, at least the complexity involved in that, at least you are communicating to the student. Though he is not solving it, but at least he is aware of the complexity. And give examples of complex engineering problems. You take specific examples like water and do a little more. At least spend 1 hour in trying to describe a complex engineering problem from your particular program. Give multiple solutions to given complex engineering problems. Because all complex engineering problems will have multiple solutions. Not necessarily completely acceptable, but they will have solutions. Technically correct solutions, but not fully acceptable. Okay. Now comes the much bigger issue. And what happens is, just because that one stupid word is there, problem analysis, people do not read what is below and immediately tick the box. Because analysis, we are doing all the time analysis. So what is big deal about it? So without batting an eyelid, people tick that box. But here if you read that sentence, you do not do any single activity of the entire PO2. No course has any right to tick the PO2. What is it that PO2 asks you to do? One is identify a problem. Do you have any course where you are the process is how do you identify the problems and formulate a problem. Identify means verbal description only. But you have to formulate, convert into verbal description into some kind of to start with a block diagram or some kind of a graph, or and then convert them into some equations and so on. That is, you go through that stage of problem verbal description to a kind of a model. And then you have to research the literature related to that. This is not my statement, please. This is given by me. And analyze complex engineering problems. Anyway, complex we have already given. And reaching substantiated conclusions. You have to come to substantiated conclusions. Using first principles of mathematics, natural science, and engineering. At least here the sequence was right. Not the PO1, but PO2, at least sequence was right. But we are not doing that. None of the PO1. So if you try to make an attempt how exactly to be done, don't immediately link it to a course. First, as a group in your department, You discuss how do I attain PO2, and then you can see through what combination of courses you can do. Okay, here the activities involved are problem identification, formulation, research literature, analyzing, and reaching substantiated conclusions. And what is involved? It involves problem statement construction, problem formulation, and abstraction, information and data collection, modeling, validation, experimental design, experimentation, interpretation of results, implementation, documentation, feedback, and improvement. A long list of things. If you are doing all that, then you are doing POC. Or at least bits of this distributed over several courses. If you are doing at least, if I am addressing even 10% of PO2, I can at least tick that box. I have a right to tick the box. Okay? No course can address all these in one course. That we accept. Yes, sir.
So we are doing a bottom-up curriculum design. I designed the courses, around 40 of them, over 8 semesters. To the course outcome, then take the PO.
No, that is not the way to design the curriculum at
So
all.
start with the POs first.
POs and PSOs, and then design the curriculum. First of all, what you have to do is, how do you address PO 6 to PO 12? Okay, what are the mechanisms that I have? How many courses, how many credits should I give them?
That's fine.
You decide that first. If I say I can maximum give 5 credits and 6 credits, you have already destroyed the curriculum.
So, many courses will map onto a particular PO. Is it okay for one PO to have only one course or two courses mapping on
Yeah,
it?
that's okay.
That's okay.
See, you cannot attain all POs to the same level. It is not expected also. Let's say you have environment, a course on environment. You have only one course, but at least you are making students sensitive to that. And whereas PO1 you are associating with every course that you are on. That's okay.
That's okay.
That's okay. Now, I will not further elaborate on this. Some activities through which PO2 can potentially be addressed. Identify complex problems that dominantly belong to your engineering branch. First, identify some problems. Create some verbal descriptions of them. And then the department can decide. Let us say, ask, instead of giving all the courses, all these complex engineering problems in one course, you distribute among courses at various levels. So every faculty member and the students are also exposed from multiple directions what a complex engineering is. And you are only describing, you are not solving. Or possibly you are exploring a possible solution. Or critiquing a solution. Okay, if you can give a good verbal description of a complex engineering problem and ask the students to debate about that, and whatever they can come together, let us say, these are the possible solutions. At least if you give that experience, they will at least experience what is the nature of a complex issue.
But certain cases, sir, the statement is not complex. For example, if I am designing a water distribution for given regions, small place. So I have a population with me. I have an area. I have a source, and I have a destination to distribute.
Yeah.
So it involves a lot of design element, but the problem is not complex. So how to
But that is complex. Where will you run your pipeline? It may not be, there are so many agencies may not allow you to run the pipeline the way you want.
Indian standards are giving guidelines. For example, rain gauge network we do for the catchments and all. So suppose there are only 2 rain gauges are there, we need minimum 5 to predict the system properly. So for that, IS guidelines are there. उसमें कोई एनालिसिस नहीं है, nothing is there. So we have to follow that system.
Okay, one is to follow we will come to that, the standards that are given. When the standards are given, it is much easier.
Yes, sir.
If the standards are not there, where do you locate your rain gauge? You put on the
Then we will apply our engineering, hydroelectric method, now we draw graphical solution.
Yeah, right now next to our department, we have one department called the Vivecha Center for Climate Change, right next to us.
Right.
Okay, the main problem they have with rain gauges and all that is that they will ask a particular building to locate the rain gauge on the terrace.
Yes.
And what happens over a period of time? They have some issue there about that location. They slowly shift it to one corner. And whatever reading you get is absolutely worthless.
Exactly.
So, but that is the issue.
That's also issue can be solved, sir. Not like
Yeah, it can be solved, but what I'm saying is, once human interventions come,
Yeah.
there are plenty of issues there.
I agree.
So in the traditional branches like civil, service HOD, or mechanical, like when you talk of ICE engines, internal combustion engines, or EVs, identifying the complex problem is not that difficult as compared to computer science, for example. When I'm designing curriculum now, if I have to design the curriculum by identifying a complex problem, it may not be as easy as doing a drip irrigation or EV or ice engines, right? It's not that easy.
Actually, what happens?
How do we identify
No. The problems in other branches are always easy.
I'm not from computer science, sir. I'm not from computer
No,
science.
again, as I said, when you take from one branch, the other problems are always easy.
Computer science people should complex problems are. But just any broad guidelines on how to identify that so that we can bring in that into the curriculum.
Yeah.
That's my thought.
We can, but it's not. This is not the platform
Exactly.
to identify the problems already. It takes some time. Okay. Justify assumptions made in formulating complex engineering problem based on survey related literature. You can build at least bits and pieces of this complex engineering problem, either at formulation level or at analysis level. You can do that. At least if you give those experiences, you are partly. If you are doing fine, wonderful. And here, design and development of solutions.
Again, complex is there.
Yeah, complex is there, yes, that won't go. Design solutions for complex engineering problems and design system components or processes that meet specified needs with appropriate consideration for the public health, safety, and the cultural, societal, and environmental
If
consideration.
you come to the lower down also it will come.
Yes.
Percolate down.
Okay. So first of all, you look at it here. You are not necessarily solving a complete complex engineering problem, but you are designing at least components of that. That is acceptable. So, as PO3 you are addressing, and sometimes processes you are designing. Okay, whether it is manufacturing process or the process you are designing. That part most of the branches will do. That's why PO3 can readily be incorporated, provided you are talking of design and development. And then comes the crunch. You have to pay attention to the public health and safety and the cultural, societal, and environmental consideration. Can we bring those dimensions at least partly
Yes, sir.
into solving the problem? Yes.
Yes.
Okay, if I look at the area I'm familiar with ECE, I don't see any of this element in that.
In our case, it's coming.
Yeah. Okay, maybe we'll have to rush through a little bit. I'll go. Then conduct PO4 conduct investigations of complex problems.
Without another small break.
Use research-based knowledge and research methods, including design of experiments, analysis, and the interpretation of data and synthesis of information to provide valid conclusions. Should we do that now? No. But, huh? Yeah. That's it. We'll finish by 4. No, finish. No, they may want. But if you take the break, then you go to 10 15 minutes. And so far, yeah, okay.
If you want to finish,
Yeah.
we'll finish.
Okay. Yeah, we are so far behind. We will next. No, I think I have to stand on my feet. Yeah, we'll continue. I had the dream of doing the next 2 hours of what you call as taxonomy of learning, but we are stuck here. But then I thought if you rush through also, it doesn't have any sense, right? So that's why it's a compromise between covering, that's your curriculum design problem. Okay, so what happens, people readily talk about PO4 if you have a lab course. But lab, the way we conduct lab is, what kind of labs do we have? It's all, there is nothing, everything is fixed. You just press a button and take a reading. Or plug a wire and take a reading. And still we will somehow apologize for that and tick this particular one. Actually, 90% of this activity we are not doing.
Survey data people. Survey data will take. Survey people survey for the pollution or governmental level or the traffic and all that can be fit into this.
Yeah, but I am looking at the area that I am familiar with, electrical and electronics. I don't say you put an AND gate and put 2 wires there and look at the output and it is an experiment. You can't have a stupider experiment than that.
So database.
But on many labs are like that. You connect something and see, maybe there are a few these days, and even if you talk about microcomputer programming, you have to write the same program, not any other arbitrary program which is correct. Whatever the teacher, whatever the manual has said, you have to implement that, and that's it. You cannot improve the program nor modify it. No. So if you put it so rigidly, it cannot effectively say that we are addressing PO4, but we still tick PO4 wherever you have a lab course, right? We are talking about research methods. Where are we teaching research methods? Okay, then you come to modern tool usage. Here we talk about create, select and apply appropriate techniques, resources and modern engineering and IT tools, including prediction and modeling to complex engineering activities with an understanding of the implications. Now when you look at it, we are not creating any tool, right? Neither we are selecting the tools. If you select, you can do an exercise, upper level exercise of selecting a tool. Which tool do you consider will meet our requirements better? You can do that, which is acceptable also. And then every department will apply these days some present day tools, IT tools like simulation or
Yeah.
yes. So at least this part, only that part we are doing it, but again, once again, modeling modeling to complex engineering activities with an understanding of the limitations. That part we don't do. So remember that even the POs that are applicable to what we are doing, we are only doing it partly. So we don't have a right to say that I am addressing a particular PO to the level 3. So if you are reasonable about it, fine. But I see in many places 3 is readily available. Okay. Now comes, I will not go into detail. Uh, we will come now to PO6 to PO7.
Yes,
Pardon? Uh, the title, the title is used with regard to every PO. And then this sentence is given to explain that. Engineer and society apply reasoning informed by the contextual knowledge to assess societal health, safety, legal and cultural issues, and the consequent responsibilities relevant to the professional engineering practice. Okay, anything that you do will have, any engineering activity that you do will have impact on the society. Absolutely, there is no question. So one needs to, what it means is, one needs to, this student should be sensitive to impact of any engineering activity on the society. And fortunately, in many cases, when you look at all the safety, legal, health issues, if you take that, one of the ways of meeting this is to use the standards. Okay, whereas it is quite common in civil and mechanical, but not at all common in ECE and EE, nor to my knowledge computer science. But the professional societies associated with these disciplines, they do define standards. Those standards will have to be brought into the curriculum. We somehow in EEE and ECE, they're almost summarily rejected. Maybe some EEE program may include one or two. But ECE can include, for example, FCA regulations. Okay, what is the amount of noise that you can generate, under what conditions your equipment should operate. None of that can be taught under electromagnetic theory. But electromagnetic theory keeps away from all that kind of requirements. Because we have to maintain the purity of not liking it ever. So they can be, one of the easiest ways to address this is to take the professional, both Indian as well as international standards that are available and pick from there and incorporate into a few courses. Okay, if you take electrical communication, I'm sure communication, when you talk about at various levels, you can talk about health issues. What kind of impact it will have? That may not be part of the textbook. That is our other problem. What is not available in textbook is not teachable. Is to be purged actually. You cannot include unless there is a textbook. Okay, so engineering society, it can be done in so many ways that itself will be fascinating one to talk about. For example, you can bring in what do you call it? Social media. That's what it is, right? Safety, legal. You have now today the whole world is influenced by the social media. Your elections can be manipulated. Now they have coined a word called post-truth society. Actually, a lot of people are doing research in that area. Post-truth, because the goal is to diffuse the rather cover the truth. Nobody knows what the truth is. That is how including American elections are being planned, right? So, for example, should ECE branch be address a little bit of social media or computer science department? What the tools are, how the social media, how it gets generated. It doesn't mean that you have to have a complete course on social media, which can also be an elective if you want. But some aspects of that, one should be able to have. For example, another one, as our keep on the increasing our bandwidth or the kind of data that we want to share, the amount of energy that we are going to spend will become enormous. At some point, people have calculated that just to uh, the kind of movies that you want to keep on seeing will consume the entire world's energy that you are producing. And people are somehow trying to produce solutions how to reduce the amount of energy that you consume. But still, nobody says that you have to reduce your consumption of the bandwidth. Everyone wants more and more and more bandwidth. So there is endless amount of energy and what you call engineering society. This is my favorite one also. You can have a course. What is the most important one with regard to uh, in engineering society? What is the most fundamental issue? Where all the issues related to that will directly impact every aspect of life. Huh? Yeah, health is one certainly. Still more fundamental.
Culture.
Huh?
Culture.
Cultural. Economics is in what way do you consider economics? Or rather, economic dimension is important at everywhere. That we agree. Sustainability, yes. The most fundamental thing is access to energy, right? If you don't have energy, you have no society. So, depending on how you have access to energy, entire world politics is based on access to energy. America was willing to destroy any number of countries just to make sure they control the source of energy. Right? That is what all the wars are about. So, you can design a course called Energy and Society to meet this requirement. It is not, we have spent time on designing such a course. It is possible to design a course under the humanities and social sciences. What is the next one besides energy? What is the most important one?
Utility.
Huh?
Utility.
Non-conventional.
Should be useful. Whatever we
No, in terms of like energy access, availability, source, all these become our central to our way of life. Right? Next one will be water.
water.
If you want, you can put water above energy or energy above water. That is your choice. But water and society, how do you interact with water? And it is so varied throughout the country, depending on the environment. What kind of water resource that you have access to. Then you can talk about habitat. You can come with a whole list of such possible courses, and I feel every program should have one or two of these courses as part of humanities and social sciences. Not every course can be included, but at least one or two can to sensitize then there is a whole set of dimensions to any engineering activity. Okay, I myself have a list of about 12, 15 courses under that can come. You can think of that. But these courses can only be designed by groups of faculty. You cannot ask some faculty member, go by tomorrow morning, come with the syllabus of this course. No, you cannot do that. Okay. Sorry. And then environment and sustainability. Environment and as essentially what I understand, the NBA is trying to combine PO6 and PO7 together. They want to leave it as engineering society, though I'm not happy with that kind of relabeling. But the environment, if you consider the most important issue in the entire world is climate change. You can have a course on climate change itself from any discipline point of view. Okay, what does it say? Understand the impact of professional engineering solutions in societal and environmental contexts and demonstrate the knowledge of and need for sustainable development. You can have a course on sustainability separately. You can have a course on environment or ecology and environment or climate change. Any of these courses will fit into this. Not all of them can be offered, but then come the ethics. It's also a very dicey issue. People have incorporated this course. Apply ethical principles and commit to professional ethics and responsibilities and norms of the engineering practice. Okay. Ethics is a little bit of very difficult to kind of offer. You cannot be saying you should be a good boy like Rama. No, you cannot offer such courses. You should behave like this. This is the correct way to do. No. The first thing about ethics is you should be responsible for your own decision making. You have to own your decision making. You cannot say somebody has forced, that's why I'm doing the wrong thing. You cannot. First of all, you have to take what we call moral autonomy. You must have your moral autonomy, that is, that you can sensitize the student. Not everyone will have moral autonomy, but at least you can say that is the issue. And the other one, every profession in engineering has, through professional societies, they have already defined what are the ethical practices. Those ethical practices in that discipline can be brought to as a part of a course somewhere. It should be possible. Every professional society will have what are the ethical practices that profession should follow. Whether it is software engineering or whether you have civil engineering, everyone will have. And some departments we have known, they offer courses specifically, I think, instead of calling it broadly professional ethics, they give a course specific to their branch.
Ethical hacking.
Pardon?
Ethical hacking.
Ethical hacking, yes. You can call it that as a course. Yes, it can be offered. There is enough material is available on the internet for designing such a course. Individual and teamwork, we don't have to overemphasize, but you have to demonstrate what you are doing, how you are measuring. Can I call somebody as a good team member? What kind of criteria do I use to? What kind of experiences, first of all, I give? How do I measure his being an effective team member? I must be able to design some rubrics to measure his behavior as a team member. Unless you do that, you cannot say that everyone hides behind what you call project. My project is done by 4 students together. So I tick all the boxes related to this. Actually, if somebody asks the next question, how are you measuring? Can you show me one particular sample that you have, how you have evaluated? You'll get it wrong. So please do address by addressing this issue, you are doing a great service to your students, first of all. Communication. Communication is something they have written it a little more in detail. Communicate effectively on complex engineering activities with the engineering community and with society at large, such as being able to comprehend and write effective reports and design documentation, make effective presentations, and give and receive clear instructions. So many details are there. Okay, first thing is two types of communication. Are you able to communicate with your professional colleagues? You use the same language, same what do you call acronyms? You do that. That everybody is reasonably comfortable with. But can I talk to my customer? Any organization that I work, can I talk to? Like for example, in your case, if you want to talk to parents, you can't use the same language that we are talking about. Is it possible for you to communicate in a language that parents understand? Or say in any company, when you talk to the customer, he doesn't understand that particular technical language. So are you able to communicate? That experience, can you give it to your students? They won't resist. They will love that if you give that kind of exercise. That is one part. Then the other one is, you have to think of writing a report, plan a report, and both we have a report on something that has happened and design documentation. I had personal experience in my department. When my master's students were writing, we evolved a particular method of design documentation. We call it design document and engineering document. And these two are given as MTech reports. When the students went for their interview, when they put the reports on the table, they said, no interview, you just join tomorrow. So the documentation effect will be that much. Okay, so that you have to give practice. You have to make them right. Somebody should help them to correct that, evaluate, make them feel the importance of that. All that will have to be true. Okay, and not only that, make effective presentation that people generally understand. They give practice also.
So just a query, when we do the project work, they make presentations, they write reports, but we may not teach them on the communication skills. So a project work in the final semester, that course, will it map onto
Yeah, it will map onto this. We have experimented with that in our MTech project long time back. We had every student make two presentations under the guidance of, we had faculty within the institute who will guide them. And also give feedback and correct it twice if they do. Everybody has become a professional in the area. It's not too difficult. And not only that, another one, we Indians are famous for not following instructions. Okay, we use it like a menu card. Whatever that I like, I will follow. You can't do that in a profession. Okay, so you should be able to give clear instructions to others, and I should be able to follow instructions given to me. Everything. If there are 10 stages, all the 10 stages I should be able to follow. And that is unfortunately very bad Indian habit not to do. Can we incorporate that? These are not very difficult things. But as I said, unless faculty build in it, it has no chance of ever getting implemented. And do not say if a report has writing part has 10 marks, you should not give between 9 and 10. So if you give 1 year, somebody 3, 4, 5, from following year everybody will pay attention. Please do that for project reports.
So this
I-
PO9 and PO10, they are connected with the last line. You see, they are mentioning individual and teamwork in the previous one also. And here also again the group is coming.
A group will come
Ah.
because in a group we are only talking about the communication. What happens here is, let's say there are 10 members in a group, in a project, in an
So
organization.
we do the survey camps, right? 10 students in a group.
Yeah, okay, but what happens, you are distributing the work among 10. Okay? Everyone will not do simultaneously hold the same instrument. So there is some distribution of work, and then having done something, you should communicate to the group in
Correct.
a well-defined form.
Right.
You cannot say, I don't like this form, I will communicate in my own way. That habit you have to pull it off. Okay? So once you work in a project mode in an organization, the project, whatever you like, somebody defines this is the way the weekly report will have to be submitted, this is the format, these are the elements of the report that you have to do. And then everybody will have to submit that. And now that is a major activity. Everybody has standardized so much that you don't even hold the meeting. On that day, you look at your email, you get all the reports,
Yeah.
it is integrated. So you have to follow. Their issue is following somebody who has defined already. You have to follow. That habit you have to follow. Not I as an individual, I will put my flag like this. This is the only way I do. That habit you have to get rid of. Then you have project management and finance. This is unfortunately, I don't know why it got thrown out of practically all curriculum. Because as I said, I'm not concerned with that. It should not be in the curriculum.
We have some. Will be.
All departments?
I don't know. Mechanical and civil there.
Okay. But the others do not have. They consider not important. Anyway, curriculum is still not in your realm. Hopefully, it will become in the near future. The issue is, in any profession that you go, in any branch that you go, 95% of the activity is done in a project. Right? Everything, software development, construction, building. There will be hardly 5% of the activities which are like what you call line production kind of issues. So, what happens, what do you mean by project? Project means you have to meet a certain goal with available, with identified financial, technical, and time resources. You have to complete a project in, let us say, 1.5 years, and this is the customer, and these are the number of persons that you have, and then you have to complete following all kinds of norms with respect to that. So that when 90%, practically all jobs will be predominantly in project mode. And if you don't have project mode experience, you will spend a lot of time and mess up with the organization also. So, unfortunately, there are well-defined courses available for this. And in fact, I would strongly suggest there are organizations like PMI, Project Management Institution, where you can have a certificate program. They give you certificate course. And somewhere during third year, fourth year, the students you can prepare them for writing that certificate. And at the time of graduation, if you have a PMI certificate, getting a job becomes much easier. Okay, it's worthwhile. And in fact, many projects they will ask you, especially large civil engineering projects, in your project team, how many PMI certified people are there? Otherwise, they won't give you contract. So, this is a fairly, in the sense, there is no complexity about it. There is a well-defined courses, textbooks, everything is available, and there are tools available from Microsoft and all that that can be given. And I think every program should have a course on project management, and no exception, really speaking, should be there. Then lifelong learning, there is no justification for this at all, no justification needed, because things change so very fast. What you learn today is already becomes dated in about 3-4 years. Shelf life of any knowledge has been reducing continuously. So what you learn by the end of 4 years is totally irrelevant by the time he joins the job. So everyone will have to learn by himself or herself. Those experiences you have to give. Learning by yourself through some exercises, you should incorporate in some courses. Once again, it is not separately you are designing the course. The department will have to sit together and say these courses will incorporate triple L experience, and then it is for the teacher to do that. Okay? So I don't have to overemphasize the rate at which knowledge is kind of growing. Now, simply if you look at any index that you take about why you require continuous change, companies that were at the top 10 years ago, if you look at the companies at today which are at the top, most of them are already out. Previous companies are out. And today, courtesy, whether it is AI or other areas, the knowledge is growing so very fast, you don't even know whether as a human being you are relevant or not after a few years. So you have to be constantly learn on the go, you don't have any choice. Or people talk about reskilling all the time yourself, otherwise you will not. Maybe in one's lifetime you have to reskill at least 2 or 3 times. So if you say my learning is done at the end of 4-year program, then that is it. You are doomed. But one thing, whatever that you do for these activities, they should be measurable. Not merely communicating, learning by yourself is important. Give a lecture and leave it like that. You have to give some exercise and define some rubrics and measure, and then you say that student has achieved this, he worked well to this extent. You have to translate. That is where the challenge is. What kind of exercises do I design, and how do I measure the student performance with respect? Okay, that is about he worked well. Now that is where we pause. We have exactly 2 hours left.
We'll make it up tomorrow.
Yeah, we'll see how much we can make it up tomorrow. And tomorrow we'll talk about the taxonomy of learning, and that is where you acquire the language of related to education. Right? Okay. Thank you. Do you want to ask any questions, or already you are tired?